Center for the Development of High Technology presents a new method for locating and contour mapping hydrocarbons using a technique involving the integrated processing of multi-zone data with varying degrees of generalization. Underlying physics of the method is based on the established principles of the migration of hydrocarbon fluids and their influences on the existing landscape, and also on the analysis of the thermal field, which is related to the sphere of thermodynamics of open systems and the theory of information. Thermal field analysis is based on the fact that the temperature field gradient changes when crossing boundaries. This technique is a supplement to the standard methods of geological and geophysical exploration and will allow oil companies to reduce geological expenditure in this area more than 500%. The primary objective achieved by the use of this technique is the determination of the extent and distribution on the ground surface of the hydrocarbon deposits. For the purposes of carrying out multi-spectral aerial photography, the following equipment package is mounted on an Antonov 30 type airplane, an Eagle multi-channel scanning radiometer, a 3-axis angle correction system, and a navigation system controlled by a personal computer with a data rendering and registration system installed on it. This package makes it possible to utilize 26 informational channels and 7 spectral ranges concurrently. The main advantage of aerial plotting by means of the Eagle-based package is greater reliability of the data because there is minimal atmospheric distortion of the results in comparison to the results achieved by satellite plotting. The following may also be considered advantages: the ability to calibrate the thermal images by temperature, brightness with predetermined specific parameters, high spatial resolution, operational efficiency, and the ease of planning and aerial photography. The more accurate formation of the mosaic images. The greatest possible angle of ground surface scanning is 70 degrees, with the scanning rate varying from 18 to 72 scans per second. Ground surface scanning from an Antonov 30 type aircraft is carried out at an altitude of 5,000 meters, which makes it possible to obtain a surface scanning zone with a width of 5,000 meters. This kind of scanning provides an unbiased picture of ground surface, which has low water content. Aerial plotting is therefore hampered in the winter months, in the presence of snow, and also in areas containing extensive water surfaces or permafrost. Scanning is carried out along parallel strips with a zone view overlap of 15%. The optimum conditions for aerial plotting are considered to be in the morning or evening in the absence of snow. Primary data processing is a complicated and labor-intensive process. Depending on the type of ground surface and the extent of the area explored, data decoding takes from 3 to 6 months. The resulting image in varying spectral range is then calibrated and linked at a spatial resolution of 5 meters, which produces mosaic cartographical images corresponding to scales 1 to 25,000 and 1 to 50,000. Radiometer correction is then carried out, providing impulse noise filtering, the correction of so-called headbanding, and the averaging of the brightness level across the photograph. Following this, the geographical and topographical mapping of the resulting photographs, images, to the actual coordinates takes place, and finally, the photographs are combined to form a single picture. The final product of the company, the images of the hydrocarbon contours, are divided into 2 groups. Those with adequate probability of the discovery of hydrocarbons, taking into consideration certain criteria. Those with a high probability of the discovery of hydrocarbons, taking into consideration all types of the anomaly criteria. The final products are delivered to the client in the form of a Geo-Information System digitizer, which permits the measurements of the coordinates of any image element in the following coordinate systems: geodesic and rectangular coordinate system. In addition to this, digitizer system permits the measurement of the area of the identified oil and gas-bearing zones onto which exploratory drilling are charted.